we've said that there's a K solubility product, and our old friend Q has come back. Q is going to help us tell whether a precipitate will form by comparison with the value of Ksp. If Q is bigger than that, then the reaction will favor reactants and you will have the precipitate. Q is larger than the amount the solvent is actually capable of holding. On the other hand, if Q is less than Ksp, it hasn't dissolved fully. So the reaction will continue to dissolve and produce products. The compounds are soluble, there won't be a precipitate, and Q is smaller than the amount the solvent will hold. Now, I will point out, if you will remember, I wrote this in alphabetical order before. And I still like to write it in alphabetical order, because if I write Ksp is less than Q, and I'm going to put Sp here because it's formed in the same way, then I can see which direction things are going to go. If Qsp is too big, then when I'm talking about my solid that I am trying to dissolve and it's in an equilibrium with aqueous products, then I can see that if Qsp is bigger than K, it means I've tried to dissolve more than I should be able to, and it's going to push it, because there's the arrow, it's going to push it backwards towards the solids, and I will have solids that come out of solution. So I am going to continue to write it in alphabetical order because of the fact that the arrowhead tells me which way things are going. Needless to say, we have to do a problem to show how this works. Here we have some calcium fluoride, and they have gone and looked up the Ksp for us, so that's nice. And we are mixing together some solutions. So you see, this is a situation where we had something that was very soluble. Think about the old solubility rules that we learned in Chem 2. This is very soluble because it's got nitrate ion. This is very soluble because it has potassium ion in it. So when you're looking at this, you're doing a double replacement thing and you're saying, oh, well, clearly potassium nitrate is incredibly soluble and I'm not going to worry about it. But what about the combination of calcium with fluoride? Well, it turns out that is not as incredibly soluble. And so when I've mixed these two things together, will I get a precipitate or will I not? What am I going to have to do with this? Well, first I should write down what the Ksp for this actually means. There's the number that they've given us. And how is it formed? Well, it's the calcium ion concentration multiplied by the fluoride ion concentration. And you can see we're taking it easy this first time. Wait, is it just that? What am I making? I should think about that for a minute. What am I making? I'm making calcium 2+, and I'm going to combine it with, yeah. All right. So I can see this should be a 2 because that's a single minus and that's 2 pluses, right? I need to think back to some of my old chemistry so that I'm making the right compound. All right. We're not going to worry about this anymore. We're just going to think about what this looks like. So what do I have? They've mixed some stuff together. This was the molarity of this volume. This was the molarity of that volume. When I add them together, I need to add the volumes. Oh, so I have a new volume. And that's going to be the 175 plus the 135 milliliters. So I'm going to have a grand total for that of 310 milliliters, which I should probably express as liters, 0.310 liters. That's fine. I have a new volume. That means that for each of these, I have a new molarity that now that it's in a larger volume, its molarity is going to drop, and we're going to have to use M1 V1 equals M2 V2, the dilution formula. Well, I just figured out what V2 is. Okay. I'm going to look for my new molarity. V2 here, though, is the 0.310 liters. My old volume, well, it depends on which one of the two that I'm doing, right? But I'm going to be doing this twice. I'll be doing it once for the calcium. I'll be worrying about the calcium. And once for the fluoride. So in the terms of the calcium, I will look and say the original volume was the 0.175 liters. And the original molarity was 4.78 times 10 to the negative third molar. Hit the calculator to work with this and end up with a new molarity. And of course, if I had put this in scientific notation, it would be 2.70 times 10 to the negative 3, which makes sense because I've diluted it, right? It's now in a bigger volume, so the number should have gone down. But that is what I will be using for my calcium ion concentration. And now I need to do the same thing for the fluoride. The fluoride ion concentration. Do the same setup where you're taking M1V1 and then dividing by the new V2, right? That's what I'm doing here. It's M1V1 over V2. If you like reorganizing things algebraically first, this is the process that you would try to do. And you would say, okay, well, what was the original molarity? Well, that was the 7.35 times 10 to the negative third molar. What was the original volume? 0.135 liters. What's the new volume? 0.310 liters. The liters are going to cancel. You're going to end up with a molarity again. And when you do that, you're going to get 0.00320. And again, you can see if you were looking at this in terms of scientific notation, this would be 3.2 times 10 to the negative 3, which is less than the 7.35. Okay, so we're believing that we've gotten the numbers correct. So if I'm mixing these together, I'm going to take these numbers and figure out what the Q solubility product is for this. And it's formed the same way. It's just going to be, what was my calcium ion concentration? What was my fluoride ion concentration? And then, of course, this one is squared. So when I put these two numbers in, I'll have the 0.00270 for this one. And then I'll have the 0.00320 for the fluoride, but I have to remember to square that one. When I put that in, I'm going to get 2.77 times 10 to the negative 8. And now I want to compare it. So what was the Ksp? They told me the Ksp was 5.3 times 10 to the negative 9. What was the Qsp? That was this one that we just figured out here, 2.77 times 10 to the negative 8. Well, that one's bigger. My arrowhead tells me it's going to go back towards solids. So I am going to have a precipitate. So we do have precipitation.